Okay, second and final video for systems of inequalities. These ones are going to be in general form, and remember what we're going to be doing here is finding intercepts. Okay, so talking about inequalities and our systems of inequalities in particular, remember nothing really changes from last section or last lecture until this one. We still need to graph both inequalities and shade and find using test points which region we want to shade. So there's probably going to be a possibility of 4 regions. Now, graphing these, if I take this first one, remember we're talking about intercepts. So to do that, first thing I need to do is remind ourselves that we need to find 2 intercepts. So the first one, I'm going to ignore my y value, find my x value by saying 2x equals 6, and so dividing both sides I get x equals 3. That means I have an x-intercept of 3. Okay, the other one I'm going to do is say that 3y equals 6, and then divide by 3, I get that y equals 2. So I put my second one right there. Now we're going to do our line, and this should be a solid line, remember, because we include the value here. We have or equals to, so I make my line, make sure to extend it in both ways as far as we can. And then I'm going to do my second one. So in green here, I'm going to say 5x equals 10. Divide both sides by 5. I get x equals 2. So again, I'm going to put a value at x equals 2. And then I'm going to do the other one. Negative 2, don't forget to bring that negative sign, equals 10. And so y equals a negative 5. And I can put a point there. And now I'm going to graph this line, doing it in green, and I know that it needs to be dashed instead of solid because I'm not including the or equals to, it's just greater than. So I draw this line going as far as I can, and I'm going to extend it in the other direction as well. And you'll notice now we have 4 regions here, just like we did in the last section and we're working on in class the other day. And we're going to need to do a test point. So I can start by plugging in 0, 0. So if I plug in 0 here, I get 0 is less than 6. That is true. So that first one, 0, 0, works in that first one, but I need to check it in the other one. Plugging in 0 on this side, I get 0 is greater than 10. That does not work. So I now know that 0, 0 is not a solution. So I can cancel out, not going to shade this region. It's usually easiest to stay on the axis, so I'm just going to come way out here, let's say where x is 10 and y is 0. So if x is 10, I get 2 times 10, that's 20. Y is 0, that disappears. I get less than or equal to 6. Not a true statement, so I know that this point is not true. So now we've eliminated 2 regions. Okay, let's just take another guess here, and let's go down, let's say negative 10 for y and x is 0. So I'd have 0. This would be negative 30 when I do 3 times negative 10, less than or equal to 6. That's a true statement. Plugging in 0 again for x, that would disappear. Negative 2 times a negative 10 would give me 20, and that is greater than 10. So that's a true statement. So down here I get both true statements, which means the region I should be shading would be down here, and I don't need to test that last one because I'm only going to have one region shaded in this case. Okay, another real quick example. If I do this first one, solving for x, I'd have 4x equals 9, x equals 2.25, so I'm going to put a point just past 2. And then if I do this one, negative 3 equals 9. So y would be negative 3, and I can put a point at negative 3. Okay, so that's how I got my first one, and then I need to draw that. So I know we're going to do it in red again, and I know that this should be a dashed line because we're not including. And so I draw that in both directions as far as I possibly can. And then I'm going to move on to my second line. So in green now, I'd have negative 9x equals 21, divide by negative 9, I'd get negative 2.33. And then my other one, 7y equals 21, so y equals 3. So I'm going to put a point at negative 2.33 and a point at y equals 3. And then I'm going to draw my line. Again, it should be dashed, and I'm going to make this one green. And it's going to look something like this. And so then we are going to try, to shade these regions. So it doesn't look like they ever intersect. Now somewhere they're probably going to intersect, but we're not going to see it. So first thing, again, we're going to start by testing our point 0, 0. So if I plug in 0, I get 0 is greater than 9, which is not true. So I can say that I know this point doesn't work. If I come way up here on the y-axis above both of them, plugging in 10, I get negative 30 greater than 9. That one doesn't work, so I know this point isn't going to work. I could come way over here and plot 10, 0, so I'd have 40 is greater than 9, so it works in that first one. And then 10, that'd be negative 90 is greater than 21, so that one does not work. So here, this could be, actually, since there is no region we see that's shaded, we could say there is no solution. This is an inconsistent system. Right, and so that would be how we graph one that's inconsistent. We check all our points and none of them work in both equations, so we could then not have to worry about doing it. Okay, and that is it for graphing systems of linear inequalities. So it's a lot like systems of linear equations, except for now we have to add that extra step in of shading an area. Okay, we'll see you next time.